record. All right, so we have a homework question from in the book. And I think you're referring to this one here in this section. Am I in the right spot?
No, it's the actual examples.
Oh,
so it's in the text themselves. I didn't do any of the homework stuff.
Yeah, so this is what we're going to work on today.
Okay.
All right, so I'm going to come, I guess I can work on this example. Did they give me information? Yeah. Back in the previous example, where's that one? P5 here. All right, so let's take some notes on this here. Suppose that 35% of all patients admitted to hospital intensive care unit have high blood pressure. 42% have some sort of infection. 12% have both problems. And then this one says, find the probability that a randomly chosen patient in the ICU has either high blood pressure or an infection. Okay, so looks like we'll need to do that first. And then down here, for those probabilities, find the probability that a patient admitted to the ICU with high blood pressure also has an infection. And the other one, okay, yeah, let's screenshot these and I'll show you how I would write them down. So this is example 5 in section 1 of probability. And we have a couple more questions. We have more people. Welcome, Bree. Welcome, Kirby. Say that prematurely. So let's walk through these. So the information above, again, 35% of all patients. So if I wanted to summarize that, there's a few ways I could do that. I could write P for probability and high blood pressure. They abbreviated that later, didn't they? So I'll just call it high blood pressure. Whoa. And so I could either write that as a decimal, 0.35, or as a percentage. So as a decimal there. And then we're given the probability that they have an infection. So probability INF for infection, 42%, 0.42. And then the probability of both, so that would be notation high blood pressure and an infection. And that would be 12%. So I mentioned the idea of thinking about these with diagrams. And so one diagram I like to draw sometimes when I'm trying to sort this out is a Venn diagram. So this box here would be all ICU patients. And then I have to consider the high blood pressure ones. Maybe I'll make those red for high blood pressure. And then let's go green for having an infection. And then let's say blue. So if I think about this, the probability that they have both high blood pressure and an infection, that's this region in the middle where they overlap. So that right there is the and, having both of them, and that's the 12% or 0.12. Now, there's some patients over here who have high blood pressure, but they don't have an infection. This 35% here accounts for that 12%. Okay, so that 12% is part of this 35. So if I wanted to like segregate these out a little bit, then if I take that 35% and subtract the 12% from it for a second, What's that going to give me? 23%. So there'll be 23% of patients that have high blood pressure, but they aren't in that group that has an infection. You put the 23 and the 12% together, that gives you the total of 35% for that whole region right there. Other side here, if we do the same thing with infections, if from that 42%, we take out for a second the ones that also have high blood pressure, that's going to give me, what, 30%? So in just this part here, this crescent shaped, that's 30% of people that have an infection but don't have high blood pressure. And there is notation for that. So I could write, what's the probability somebody has an infection and not high blood pressure? So that would be this region right here. That's that 30%. Now, the first question was asked, well, what's the probability they have a high blood pressure or an infection? And an or is usually an addition, but we got to be aware of that overlap there. So I want to find probability that they have an infection or they have high blood pressure. At first glance, I would say, well, 35, or sorry, I wrote those in different order, 42% of them have an infection, okay? And, right, or 35% have high blood pressure, but I just double counted that 12%. That 12% is in there and it's in there. I gotta take that away. So we went over this rule the other day. So I'm just warming up to the question Tammy really wanted, but I wanted to review this anyway. So cleaning that up, let's see, that's going to give me what, 77 minus 12 is 65, if my arithmetic's okay. Alternatively, I can look at the other way I broke it down here. 23% have high blood pressure but non-infection, 30% have an infection but not high blood pressure, and 12% have both. So my picture playing around shows I should be able to take 23% and 30% and 12% and add those up. And what do we get when I do that? I get 5% there and 60% there. So there's that same 65. And this is that formula I talked about the other day, that if you have two things going on, two categories, A and B, you want to know about A or B, and you take the probability of A plus the probability of B, oops, and you minus any potential intersection that they have in common, A and B. Side note, sometimes they have nothing in common, right? So this is what's in common. If they have nothing in common, that would mean that that probability would be 0, right? 0, nothing. Then the two situations are said to be disjoint or mutually exclusive. Disjoint, sometimes we say mutually exclusive. So often books give a separate formula that says, hey, just add them up if they happen to be disjoint. But the safer thing is to just always use this formula right here. And sometimes that and ends up being a 0. So what? If it is 0, that just means the two original events had nothing in common. Do patients with high blood pressure have something in common with people with infections? The answer is yes, they do. So sometimes there is something in common, sometimes there's not. There's nothing in common, they're said to be disjoint or mutually exclusive. Mutually, together, exclusive, they exclude each other. All right, let's look at the next part. With the high blood pressure also has an infection. Okay, so let me just bring this to a new screen since this got a little messy, that problem. So back to those other probabilities. So I need to know those up front. So the probability of having high blood pressure is 35%. The probability of having an infection is 42%. And the probability they have both, high blood pressure and infection, is 12%. Okay, now find the probability that a patient admitted in the ICU, right? So we're still in that universe, with high blood pressure also has an infection. So this was mentioned in the book, and I mentioned this in class the other day. English language is very varied. There's lots of ways to say something, and sometimes it's not very precise. And often I'm going to switch to probability notation to try and be a little more precise. So I got to figure out what this means in terms of probability. When someone says also, I think and. So is that right? Probability, am I reading that right? Find the probabilities that a patient, oh, no, I'm not reading that right, am I? Find the probability that a patient admitted to the ICU with high blood pressure. So they're saying, we know this also has an infection. So that would be the probability that they have an infection, knowing they have high blood pressure. Another way to state that. Let me make sure I'm reading that right. This is why I went into math, not English. Math is more precise. Find the probability that and often with these probability problems, I got to read the situation multiple times, trying to figure out what the heck they're saying. Find the probability that a patient admitted to the ICU with high blood pressure. Okay, so we have a patient in the ICU with high blood pressure, also has an infection. So thinking about my picture, to analyze this. So here's my high blood pressure people. Oops, wrong order. Blood pressure. And then here's my infection people. So I have a patient with high blood pressure. So that means all I care about right now is this circle right there. All right, so in that circle, what's the probability they also have an infection? So if I just said maybe there's 100 people in the ICU total, all right, so I have 100 people here, and either they have high blood pressure or they have an infection or both. Of those 100 people, 12 of them would be here. 23 would have high blood pressure but not an infection, right? That gives me that total of 35 up there. And then 30 of them would be right here. And 30 plus 12 gives me that total of 42. So out of the high blood pressure people, so that's my new denominator, the 35, how many of them also have an infection? So that would be 12. So I can kind of look at the picture and get that out of that. The other notation for saying that we know some information about them is the probability they have an infection if they have high blood pressure. And the formula for that is find all of them, or find the probability that they have an infection and I went over this formula last time, high blood pressure. There we go. Divided by this knowledge right there. So that changes the denominator, the probability that they have high blood pressure. Okay. So the if is that knowledge. And again, it's you got to get used to reading these to kind of figure that out. Find the probability that a patient admitted to ICU with high blood pressure. So that gives me that if.
That's about as clear as mud for me.
Sorry, that's not.
That's all right. I don't know. I guess it's just getting used to, because when I read that, I was like, oh, it's and. So there's
and that was my
formula.
first. That was my first look at it too, until I read it again with the with right there. So if we write that sentence out again, is put it all together instead of different lines. And again, this was mentioned in the book, and I mentioned this in class the other day, the English language is very varied and not very precise, and trying to put that in probability language also is often difficult, and it takes some experience. So what is the probability a patient with high blood pressure also has an infection? And that's definitely a common, like I did at first, think, oh yeah, that's an and, but the key, I guess, here is that we have a patient with high blood pressure. And so that sets off our new denominator, our new universe. All we're thinking about now is high blood pressure people. We just focus on that group. And so that's why we have to change the denominator. We'll do a couple more of those and try to get more used to them. All right, part B, find the probability that a patient admitted to ICU has high blood pressure if an infection is present. So here they're stating it a little bit differently, and they're pretty clear this time about the if. So for part B, get this on your screen. And the probability that a patient admitted to ICU has high blood pressure if an infection is present. So they're using more language similar to probability notation. So the probability of having high blood pressure if an infection is present. And other notation you'll see for that is, again, probability of high blood pressure knowing they have an infection. And I like the knowing better than the if. This book likes the if. And a shorthand for that still is probability of having high blood pressure. And sometimes you just see a straight bar in the middle. Infection. And that straight bar right there just is an if or a knowing. So in this case, we'd want to find the probability that they have high blood pressure. Oops. And have an infection divided by that new knowledge here. I only want to focus on people with an infection. So that, and that was that 12%. And the infections, that was 42%. And then rounding to think about here kind of depends, but let's go to a calculator. Those two answers. So for the first one, we have the 12% of patients, I'm going to call it 0.12, divided by the high blood pressure people, which was 0.35. And often when we divide those, they come out to these decimals that just keep going. And the usual rule is to go to the nearest tenth of a percent. So a percent is out of 100. So that would be the percent part, and the 2 would be the nearest tenth of a percent. The 8 says round it up. So I would call this 0.343. The previous one. Approximately, or we could say 34.3%. And in the homework, just pay attention to whether it asks for a decimal or a fraction, or if it has the percent symbol outside the box. The next one, we take that same 12% but divide by the 42. So what the rounding comes out on that. So we get 2857, so 28.6%, 0.286. Rounded, usually when I round, I put a wavy equal sign just to remind myself and others what the heck happened there. So another way to state the answer. So another thing about these formulas, so the conditional probability. So that would be the probability of some event A happening if we know event B happened, is always the probability of A and B divided by the probability of B. And often this rule is rewritten as a multiplication rule. So if I multiply the probability of B to the other side, then I can, and then state this and first, the probability of A and B is equal to the probability of B times the probability of A if B. So we're just going to take a look at the implications of this rule next. If we rewrite the conditional probability fraction as a multiplication.